I want to end this lecture set, lecture 4, with some notes on testing and debugging. So when you write a program, in the future we will set up many programs with classes, so it's going to be a little bit different, but the same ideas still follow. And these ideas we sort of used in Csis 235. If you remember the book uses stubs and drivers. What are stubs and drivers? Let's take a look at what you do if you have a big program with many functions. That's what we will do, the kind of thing we'll be doing pretty soon. We want to have each function designed, coded, and tested separately. You want to ensure the validity of each unit. So if you have a, let's keep it simple. We just have a whole bunch of functions. You have each one in a separate .cpp file, and you test them. You test each one separately, and these are also called unit tests, and when they are actually more formalized. But right now we're not going to do things like unit tests per se, but it's the same idea. So the basic approach is divide and conquer. You take if you have many functions that implement one big task, you want to take each of these smaller manageable functions that implement this big task and test them separately. How do you test them separately? Use driver programs. What's a driver program? It's just a main function. That's it. For our purposes, that's all it is. There's a simple example that's given in the book, display 4.9, and you have a function that's sort of, you could say, refer to this as the function under test. Is unit price, simple function with an int and a double, 2 parameters, and it's given below. Here it is. And typically what you do is you have this in a separate .cpp file, and then you have a separate main program, but here we have it in the same thing. We have a main program that tests this. So it just calls this maybe a few times, in this case, based on inputs from a user. So typically for unit tests, what we will do is we'll have everything. For actual unit tests, we'll do the same kind of thing. We have something that's under test. This would be the function under test. We would call it from a test setup where we have all the inputs already and we just automate it. We run it, check it, we know what the answer should be, and we run a whole bunch of tests on this function under test. So this is called a driver or a test driver. The same idea, and you've seen this from Computer Science 235. These are the kinds of inputs. In this particular case, you're getting user input, and you're having the user check. If you automate this, you have the inputs all lined up and the answers that they should be returning as well. Okay, so what happens if you have a whole bunch of functions that all work together? Well, you want to develop incrementally and write out some of the less complicated functions first, probably, and write the big picture functions first. That is, so it depends. Let's say you have a function to open up a file. Check and make sure it can open up a file, and you can, let's say, and then you can maybe test actually putting things into the file, like low-level functions, like exactly what kind of things do you put into that file. Do that last. If you have functions that you need to implement but are not done yet because you're still testing the big picture functions, then you can stub them out. Stubbing it out just means that, let's say you're supposed to implement something, takes 2 inputs, an int and a double, and does some computation and returns something. Well, returning just any old thing like 0 probably is not good, but you could return something like 9.99, and you can, because you can recognize this is not really implementing the function of this unit price function. All it is satisfying the compiler by returning something valid. And then later on, so this is called a stub. So a stub is just sort of like a skeleton, you could think of it like that. It doesn't really have all of the code. It just has some basic code that satisfies the compiler so that you can call it and it'll give you some valid some input that's syntactically valid, but it's not necessarily, doesn't actually perform its function. So if you call this function, those calls will still work, but you're not getting valid output back. It's just a temporary. Okay, so the fundamental testing rule, to write correct programs, that is programs that have correct behavior, you want to minimize errors, that is bugs, and you want to ensure the validity of all input. So test every function in a program where every other function has already been fully tested and debugged. Avoid cascading of errors, that is, one function has has a bug in it, and if it calls some other functions, then those errors propagate, and it might be very hard to trace where the error popped up. Okay, so this is our first look at functions. Now we'll revisit all of these things in the context of classes again, and that's going to be coming up real soon.